All right, can I have everyone's attention? See the last people coming in. It's time for our next speaker. So I want to have a warm welcome for Rodel van Rooijen. He's a machine learning engineer for Achmea, and he's going to talk about building a data platform from scratch. So, warm welcome, please.
First of all, thank you all for coming to this session today. I have to admit, it's been a while since I've last presented at a conference. Almost 5 years ago, I presented back then, also in Amsterdam at the Spark Plus AI Summit. Ironically, about the same topic I'm presenting on today, building a data platform. However, in the meantime, a lot has changed, of course. When you think about tooling, but also from my own perspective. Back then, I was helping build a data platform on-premise. In the meantime, I went from building an on-premise data platform to joining a startup, where I've helped building a data platform from scratch. That's also why I'm here today. I want to share a bit on my experiences, going from, on the one hand, building an on-premise data platform, to building a data platform at a startup using cloud technologies. Before diving into this in a lot more detail, first I want to give a short introduction about myself. I'm Rodel. I have over 8 years of experience in building data infrastructure and data products with and without machine learning. I started my career at ING as a data scientist. After that, I worked at Adyen, which you might recognize from these ones. There, I worked as a machine learning scientist on the first use cases of machine learning in production. I also was a tech lead and engineering lead there. Then I joined Solvimon, which was founded also by ex-Adyeners. And there, I've helped build a data platform as founding engineer. And I've also helped build a data team there. Right now, I'm working at Achmea as a machine learning engineer. During the presentation, you might see a few of these QR codes popping up. This is just extra material. So in terms of some extra material from my side, for example, this is my own website. So if you want to learn a bit more about me or read more about the material that I write, you can just scan this or go to my website to learn a bit more. Let's go back to the topic at hand, building a data platform. Let's imagine now that you have your typical tech startup. Your typical tech startup where you have an idea and you want to develop a go-to-market strategy, and let's say that's successful and you want to now scale the company. At that point, a lot of startups will hire their first data engineer. From a founder perspective, it might go a little bit like this. So the founders think, well, now we have some traction, we can scale the company. We also have some data, right? So now we can do useful things with that. Well, this is also the moment where they say, let's now add some analytics. Let's add some extra analytics on top of the product that we have. Or let's introduce AI, right? Everything's doing something with AI. Let's also do stuff with that. Well, the thing is, without a data platform, without something that is early introduced in a company, it's very difficult to achieve this from the start. And that's why I want to share a bit of my learnings today also on why would you build such a data platform? Well, this is one of the reasons, because from the start, thinking about having a data platform and introducing it and really building it into the core product that you have can really make the difference. I also want to spend a bit more time around how can you build such a data platform and how I did it on my end and the challenges that I faced in making a lot of decisions there. And on the last note, I also want to give a bit of an idea of what are the first data products that you can build. How can you add value on top of a data platform? It's not trivial, but I want to give some insights into how I approach this. Let's go into a bit of matter on why is it so difficult of a topic. Well, the thing is, a data platform consists of a lot of different components. And here, I will just give you a few of the highlights, I would say. And even the highlights are already a lot of different components that you have when it comes to having or building a data platform. For example, the first step I would say is having a continuous integration and continuous deployment layer, where you can test the changes that you're making, for example, in the data platform when it comes maybe to data quality aspects, code aspects, continuous deployment, for example, where if you make changes to your data platform in terms of code or in terms of other components, that you can continuously deploy those changes in an easy way. In a lot of cases, data platforms now also introduce a change data capture layer. This is a layer which makes it much easier to have let's say, your changes captured from, for example, a database that you already have to some other location, for example, a cloud storage location or a data warehouse. An orchestration layer. For example, when it comes to data pipelines that you have in your data platform, you probably want to orchestrate them in a certain way. For example, with schedules or things like that. A batch and streaming transformation layer. As you can imagine, there are a lot of different components here, but you can also think of, for example, the batch transformation process of your data or the streaming transformation process of your data. Usually you have, for example, your raw data at hand, but you really need to harness that raw data, transform it in a way to make it usable. Then you also need to think about storage. So I have my raw data. Where do I store my raw data? Do I store everything in a single place? How do I deal with my transformed data? How do I approach that kind of problem? And on top of that, you need a querying layer where you can query the data that you have stored in a certain location. And you can make it easily accessible, for example, for your organization or for your customers. And then lastly, a visualization layer where, for example, you can think of BI tools or a different front end when it comes to harnessing the power of the data that you have. And then, for example, building insights on top of that or different things that might matter internally but also externally. As you already see here, these are examples of components of a data platform. These are already a lot of different aspects that you have to think about, that you have to make a decision on when it comes to building a data platform. But this is not the only difficulty when it comes to a data platform. Because if you really zoom into these different components, there are a lot of different tooling options that you can pick from. These are some examples that are just coming from my own experience of tools that I, for example, have dealt with or tools that I have seen. And you can already see that for all these different building blocks, there are just so many different choices, and each of them have their pros and cons. What I'm here today is to give a bit of guidance on this. So when you're starting, let's say, when building a data platform, or when you want to introduce some of these components into maybe an already existing data platform, I want to give a bit of insight into how I've dealt with this and what the starting point can be when you're making such decisions. The thing is, you'll probably still feel a bit like this, but hopefully, with the guidance I give, you feel a little bit more at ease. But that's just what I hope. All right. Let's go to the first pieces that I would say are very important when it comes to, for example, picking tooling, but also when it comes to building a data platform. I would say the first thing that is of importance is to really think about the cloud platform that you would like to use. Cloud platform, I say, of course, you can also try building it on-premise, but the assumption here is you use a cloud platform as a starting point, and that's also the building block that you'll use to build the data platform. These are just some examples. Here, of course, are the main three cloud platforms, but it's very important that either you already probably have an existing cloud platform or you have a cloud platform that you still need to pick. Really do that carefully and look at the tools that lie underneath it and data tools also that come integrated into these cloud platforms. Another point I would say is very important is use the knowledge that you already have, or your team already has for that matter. It's very important not to invent the wheel. And also when it comes to, for example, harnessing the knowledge that you already have, it can come with a lot of speed benefits. So use that. And on the other hand, I would say from my own experience, use open source where possible. There's a lot of different, let's say, tools and also a different spectrum when it comes to tools that you can pick from. But if you pick the right tools and the right open source tools, for example, you can really harness the power of a community that's behind such a tool. And it really can make your life a lot easier by harnessing that community and by using these type of tools. Let's zoom a little bit deeper into this. When it comes to picking tools, but also when it comes to different, let's say, different spectrum of, let's say, the components that you can integrate in your data platform, I would say these are the three main angles how you can look at it. On the one hand, you can, of course, choose to self-host something. for example, an open source tool that you come across on the internet and you say, well, let's try it out. Let's try to self-host it. Let's spin up a virtual machine and let's just try and use that. This is the self-hosting option. And of course, it comes with full control. You have full control over what you deploy. On the other hand, it comes with a high degree of flexibility because if you want to change it up, well, you have control to change it up or integrate it with something else. It also has the lowest immediate cost, meaning that usually these tools facilitate quite well to spin up a VM and just deploy that. However, there are definitely some pitfalls here. It is the case that it might have the lowest immediate cost in the short term, but definitely looking at the longer term horizon, it comes with additional maintenance that you need to have. And also the expertise in your team might need to be a lot higher if you want to do this in the proper way. On the other hand, there's kind of a new sort of tool also popping up, which I would call the managed version of the open source tool. You can think, for example, if you're familiar with Airflow, you can think of Astronomer. Or if you are familiar, for example, with Spark, you can also think about Databricks as a managed option. These tools have a lot of stuff already built in. And you definitely need less expertise when introducing these kind of tools in your data platform. Also, when it comes to the flexibility that you still have that decent flexibility because in the tool itself, it's still the open source tool that it uses. And on the other hand, it usually also has a lower implementation time because a lot of things will already be dealt with for you. On the other hand, you give up a bit of control, of course, if you go for such an option. And it can also become more expensive, of course, because, yeah, well, it's not for free that you get to use this tool. On the other hand, you also have the proprietary option usually. So this is the option where you use an already built-in tool, closed source, and you just go with it. It usually also has a low implementation time. But on the other hand, you also give up a lot of the flexibility and control that you might have over that tool. So when you come to make a decision on this, really pay attention to that aspect. In my own experience, for example, when it comes to data orchestration, I have experience with Apache Airflow. So also when I looked at, for example, how I would build a data platform, I naturally went and be like, all right, let's just try Airflow, and let's just try and see if I can make my orchestration layer with Airflow. And I looked at the self-hosting option, and I was like, I can spin up a VM and deploy Airflow on that, but I want to have it a bit more scalable, so I would probably opt for Kubernetes and Airflow, and well, Airflow facilitates that, so great. On the other hand, Google, so it was the cloud provider that the startup I was working for was already using, had a managed tool which kind of made Airflow available out of the box, called Cloud Composer. On the other hand, Google, for example, also has a proprietary option called Google Workflows, where you can probably also build out a lot of that functionality in a proprietary way. All right. So in the end, I wanted to, let's say, just start with something. So I went with the self-hosting option. Of course, this comes with implications, but I'll get to that a bit later. The self-hosting option. Maybe some tips from my side. I mentioned you can just spin up a VM in the cloud and then just start using the tool. I would say try to think about this a little bit more in a scalable manner. So first of all, I would say pick a managed Kubernetes platform that you can make use of. This makes life a lot easier, and it takes care of, for example, scaling issues that you might face in your virtual machine, or other things that might be out of the box available to you. I would say it really depends on the cloud platform that you pick, but this is a good starting point when it comes to self-hosting services. On the other hand, I also have some material available that can help you, for example, set up open source tools on a Kubernetes platform like Google Kubernetes Engine. And it also showcases a bit of the conundrum between, all right, so how can I scale my services then? And I would say the first point of importance is really when it comes to horizontal scaling. So for example, when you deploy your tool and you find out, all right, maybe with Airflow, I want to have a bit more schedulers. Like I want to have a bit more power when it comes to the scheduling operations of my orchestration layer. Well, that's the moment where you probably also want to spend a bit of time and think about the horizontal scaling that you can do. And if you're curious, this repository contains a bit of material that you can use to set up that yourself. On the other hand, I would say a lot of open source tools make life easy when it comes to deploying on Kubernetes. A lot of these tools either have community Helm charts or Helm charts, official Helm charts, that help you easily deploy this yourself. Also, if you look really into what you can still customize, it's a lot. A lot of these Helm charts, they come with pre-configured values that you can still change up. For example, with Airflow, I mentioned schedulers. Well, you can pick the amount of schedulers that you want, the amount of CPU that each scheduler has. Like, you can still customize a lot of these things, and it's an abstraction layer that can make your life a lot easier. All right, so now we dealt with this. Still a lot of choices and a lot of, let's say, options that you have. I'll now dive a little bit deeper into how I built the data platform at the startup that I worked for. 2 starting points. So on the one hand, there was a given already. So the startup which I worked for already picked Google Cloud Platform as their cloud platform. So it was a good starting point to also, let's say, just see what's possible there. There was a Postgres database which contained almost all the data that I could think of that I could use at the startup. So it's a good starting point to use that. On the other hand, I needed to come up with requirements. So what are the requirements that my data platform should satisfy? And there's a lot of, let's say, different aspects here, but the points of importance really were it should be able to handle large quantities of data. It's not at all startups that you have this requirement, but when it comes to, let's say, the data platform I was building there were huge amount of events that were coming in that have to be dealt with. So this was really a hard requirement from the start. It should be able to handle that. On the other hand, there was really a need to improve internal analytics. So this was, of course, a necessary given. So I needed to take that into account. From my end, I preferably really wanted to use open source or manage open source tools, for that matter, for the reasons that I've already mentioned. And on the other hand, of course, it's very important to keep costs under control. So what were the first choices that I had to make? I think the first real, let's say, choice I had to make was around the storage and querying layer. Here, I think that this choice really influenced a lot of different aspects when it comes to building a data platform. For example, when it comes to the options that are at hand, these options can also, for example, come with a lot of different components already built into them. So these are the 3 options I would highlight here, and the 3 options I looked at mainly in the beginning. So I looked at BigQuery, already available in Google. So, well, the startup also already experimented with this, so why not go for the option that's already available in the cloud platform? On the other hand, Snowflake is a really, let's say, extensive ecosystem that can help with a lot of different aspects, from data warehouse to machine learning to a lot of these different things. And Databricks, well, I was already familiar with Spark, so Databricks was kind of comfortable to look at as a solution. In the end, I compared these different options, and I realized that when building such a data platform, speed is of the essence. So if I would have introduced Snowflake or Databricks, there would definitely be that longer implementation time. That's also the reason why, in the end, in this situation, I went for BigQuery. BigQuery also offers a lot. And there, I think, I really tried to also look at the role that BigQuery played, just in general. So let's now let's look at this and let's treat this as a given. I mentioned that we have our data, for example, in a Postgres database. The thing I wanted to introduce was to capture these changes and then transfer them to the data warehouse. And this is where the change data capture layer came in, which I already mentioned. In the beginning, I looked at a proprietary tool by Google called DataStream, which can make your life a lot easier when it comes to, for example, capturing all the changes in all the tables in Postgres and then transferring them to BigQuery. Also, for example, when it comes to schema changes, it can automatically deal with these kind of things. The thing is I didn't really pay attention to the cost aspect of things, and it was a usage-based pricing model where you really pay for the amount of data that you transfer, and given that that was terabytes of data, it was quite expensive. So that's also when I started looking at alternatives. And I came by an open source alternative called PeerDB. And PeerDB is a pretty interesting tool because there, instead of paying for the amount of data that you transfer, you just pay for the compute itself. And that can be a lot more cost efficient. Here, went for the self-hosting option, just to give a bit of speed in the beginning, but there's also the managed option there that was easily to switch it out. Then the second point I think that was of importance to make a decision on was the transformation layer. So all this raw data, all these events, they somehow needed to be transformed into usable data. The first kind of conundrum that I faced was about the streaming versus batch situation. On the one hand, you want to make data available as quickly as possible, and a streaming tool or streaming transformation layer can really help with this. On the other hand, the streaming transformation layer can introduce a lot of complexity when it comes to your data platform. For example, when you think about backfilling your data, or really thinking about, all right, how can I maybe rewind certain things from happening? A batch process makes this a lot easier to start with. So that's also why in the beginning, I thought, let's keep it simple. Let's treat this as a batch process. And let's look at a batch transformation layer from the start. BigQuery also offers the capabilities to do all these data transformations inside BigQuery itself. However, also there, the cost aspect of having just a lot of data really can become a problem. So that's why, in the end, also based on my own experience, I looked at introducing Spark, where you can integrate Spark, for example, with BigQuery, where you just pay for the compute. So you can pull your data from BigQuery. You can make your transformations in Spark, even in a streaming manner if you want that. But this is in a batch manner. And then you can transform the data and then directly put it back into BigQuery. I already mentioned Airflow. Well, Airflow was the orchestration layer I was already familiar with. I went with that. Then I would say the last real choice at the start of this data platform was around the visualization layer. So I was already familiar with Looker, so why not just use Looker? Well, also here the cost aspect came in. As a startup, you cannot really afford Looker. It's very expensive to start with. Think about at least 100K a year to start with as a license fee. So start looking at alternatives, and 2 open source options came by. There's a lot more, but 2 open source options came as kind of the first things I was considering. Metabase, an open source option that offers a managed BI tool, but also the one that you can self-host, and Superset kind of in a similar manner. The thing is, Metabase already came with a lot of things out of the box, and therefore, when also comparing all these different tools, Metabase really had a lot of things built in which made our life a lot easier. So that's the option in the end that I picked. All right. This is, of course, already a lot to take in. So if you want to read a bit more about it, feel free to scan this QR code, and you find a blog post where you can read more about this. All right, so I still have a bit to go. Let's go into how can you now add value using a data platform like this? Well, I think you really have to think about this from the start. And we also did this on our end. And one of the things we wanted to accomplish was something called embedded analytics, where inside our front end, we would be able to offer our customers a fully customizable analytics experience. We chose Metabase also for the reason of it offers the capability just to host an iframe inside the page and then just offer a fully Metabase instance for your own customers. Really powerful. If you want to read more about this topic, also here, scan the QR code. In the end, we found out that, well, iframe, great, but when it comes to really having your, let's say, own influence on how it looks like and all these kind of things, this is really something that probably you want. And therefore, there's another tool called Embeddable, which can really help with this. All right, last thing. Most companies deal with this problem when it comes to importing data and exporting data. So importing, for example, is retrieving data from somewhere, or your customer importing, for example, maybe their own customers, or maybe data that they want to use historically into your own system. Or exporting data, for example, the data that you have made available for your customers, and then directly export that as downloads or cloud storage. I want to give a bit of an example of how the latter can look like if you harness your data platform in the right way. Well, first of all, the starting point is, of course, you already have some sort of front end that handles authentication and that sends information to your front end. I would say opt for a middle layer, meaning that I introduce the data platform mostly as somewhere that you have, let's say, your data, that you can transform your data, and that hooks up to a BI tool. This is, of course, not really a backend, but I would say make your life a bit easier by introducing a layer in between your backend and your data platform that your, let's say, data team can still be responsible for. It's just a Python middle layer, and it can be very simple. For example, it should just list maybe the options of imports and exports that there are, or it should just help initiating a new export or import setup, and these kind of things. How can it look like in the data platform itself? I already said Airflow was the orchestrator which I picked. So I think it's very powerful to, if you have an orchestration layer, to harness that in the right way, such that you have one place where you can view all your data pipelines and see whether something is going wrong. This is also where Airflow came in. So Airflow is responsible mostly for initiating, for example, the setup of a schedule when it comes to exporting data to maybe some other location. It's also responsible for communicating with another ETL tool called Airbyte here. Airbyte also is an open source tool and is very powerful when it comes to facilitating importing data or exporting data, just an ETL process from different locations. So, for example, from a cloud storage location to a data warehouse, or data warehouse to cloud storage, anything in between, Airbyte can facilitate. So Airbyte also handles the import and export connection layer really to, for example, your customers. Your customers would then enter, let's say, your front end. They would just give in their credentials, and then your data platform can take care of the rest. I think this is very powerful. When it comes to thinking about first use cases of harnessing data, this can be very powerful. All right, let's summarize this a bit. I mentioned startup. But in general, I think it's good to start early when it comes to designing, building, or scaling a data platform. Don't wait, because the longer you wait, the more difficult it will be to, for example, hook up your backend with your data platform. And you really start to see that barriers will appear, where it's difficult to start and break those. Use what you're familiar with. I mentioned this. I think using your own experience or experience that your team already has is very powerful and can really give you a speed benefit in the beginning. And on the other hand, design your value-add products early on. I mentioned here, I mentioned embedded analytics as a self-service product, import and data exports. It's really important to start thinking about it from the start and then thinking about, okay, how can I make the best decisions when building a data platform to facilitate this? All right. I also have an announcement to make because I was announced, let's say, currently working at Achmea, but pretty soon I'm going to join Palm, where I'm joining as a data and AI lead. Palm is a treasury management system that's primarily responsible for cash flow, let's say for cash management, so cash flow predictions, but also transaction categorizations and all of that. And I also want to mention that we are hiring. So we are remote, and that we're hiring backend engineers, machine learning scientists, and data engineers. So, thank you.
All right, then we have a couple of minutes left for questions.
Thank you for your talk.
It's done?
Is it done?
Should be on.
Yeah.
Yeah.
My question is about AI. Where would you put AI in this chart? And what is your thinking about this? So which options would you consider, and what would be your preferred option?
So if I heard the question correctly, it was about embedding AI into this kind of situation,
Yes.
right? I think that's an interesting point, and I think it's it depends also on, I think, what type of AI you want to introduce, of course. But when you think about, for example, the cloud platform that you might already be using, then each cloud platform also offers their own AI capabilities. So it's a good starting point to really look at, all right, what does my cloud platform already provide? For example, in Google, you can think about Vertex AI, where a lot of capabilities when it comes to AI is already built in. I would say also look at alternatives like Snowflake and Databricks. They are, let's say, quite extensive solutions and come with a lot of AI capabilities already built in.
They're expensive. They're expensive, right? Databricks and these kind of things. But for startup, what would you advise to do with AI? Preferably open source.
I only understood the last part, so around AI, let's say open source AI.
Yeah, and take into account budget, because for exploration, it would be nice to have low budget for this.
I understood maybe like give an example maybe of an example project maybe in terms of AI or like.
For example, text to text, text to speech, speech to video, text to video and speech. So this kind of AI possibilities.
Yeah, I would say also there, when you think of, for example, so either on the one hand, indeed, like open source AI that you can pretty much plug into a data platform like this. You can think, of course, also the keynote speaker, she worked for Hugging Face, where I think a lot of stuff is already made available for you that you can use, for example, in an open source manner. If you look at Google, Databricks, of course, they have their own solutions when it comes to introducing AI. I would say it really depends on the business that you're in and what type of, let's say, AI could be beneficial, of course, to introduce. But the starting point, and also I think I wanted to give that measure also in this presentation, the starting point is harnessing your data. So analytics, you need to be able to do that in the right and in a scalable manner, and then you can, I think, introduce AI in a scalable way.
Hey, I had a question about if you have been here.
Oh, sorry.
If you've been in a position of having to justify to the business the cost of hosting a data platform. I think, as you said, all of these tools are very expensive, especially as a startup where maybe whatever tool they're providing is more important than internal analytics or this kind of stuff. So I was wondering if you have any tips for having this kind of conversations with business.
Yeah. So I would say, of course, cost is a matter of importance. And I think when dealing with picking certain tools, that's something that you have to take into account from the start. On the other hand, when dealing, for example, with cost, I would say think about it in the other way and think about monetization. So I gave a few examples, for example, when it comes to value-add products that you can build on top of a data platform. Think about how you can monetize that and discuss with your business in terms of, if I add this to my product, how much value can it bring? Can it bring more customers? Because that's direct value. Can it maybe have, let's say, maybe a pricing, let's say, you can have maybe a pricing discussion. I think that's quite important to already involve the business from the start when picking these kind of tools and be like, well, we can already provide value with this. But yeah, keep costs in mind and therefore also open source and hosting things yourself might come at a lower cost, but just keep in mind all the other considerations.
Thanks.
Thank you for the presentation. I had a question about the three different tools that you use for storage, querying, and transformation. It was BigQuery, Spark, and Airflow. If you were to replace that with, say, just Databricks, how would you compare your setup versus Databricks in terms of cost, resource, and speed?
Yeah, I think good to mention. I think I didn't mention this explicitly in the presentation, but big data transformations, Spark mostly in this design, and small data transformations mainly in BigQuery, also because of speed and just simplicity there. If you would look at, for example, Databricks as a solution, I think there you would use Spark for everything, I would say. And of course, that can simplify things a bit more. On the other hand, Databricks requires a bit more technical expertise, for example, handling Delta Lake tables and all these kind of things. There's a lot of benefits to it if you, let's say, already have a very technical team and want to, let's say, do it in, let's say, the Databricks manner. On the other hand, something like BigQuery is more of is closer to your traditional SQL database, data warehouse. So that can come with benefits, for example, if your business is already familiar with that. Are there very big differences? Technically, if you look under the hood, yes. How it really works and cost-wise, it probably doesn't matter a lot. But it of course depends on also the scale of data that you're using.
So the choice would depend on how is the technical team, for instance.
Yeah, and as I mentioned, also what you already have experience with. So if, for example, you are already using Spark a lot, Databricks is a pretty good option. But if your team is pretty much, let's say, only used to doing SQL, then yeah, I think then Snowflake and BigQuery are much better options.
All right. Hello. Yes. That was the time for questions for now. As a small token of appreciation for the talk, we have a small mug for you.
Okay.
And give one final applause for Rodel van Rooijen. We're going to have lunch now. So at 1:40 we're going to continue the program. And for now, enjoy your meal, or eet smakelijk, as we say in Dutch.